Hi gang, today we're trying a new experiment. I'm going to put some ice into room temperature water. This is a calorimetry experiment. We're going to see if we can calculate the heat of fusion of ice. The ice has been sitting out. We don't want to take it directly out of the freezer because we're going to try to get the ice at 0 degrees. It has been sitting out for probably an hour. You probably can't tell, but it's in a pool of its own water as it has started to melt. So we're assuming that the ice is about 0 degrees right now. I have some room temperature water. I measured about 75 milliliters of water. We don't need that exact volume because we're going to measure precisely the mass of it. So I have my calorimetry equipment. The styrofoam cups, I'm going to just zero the balance out. We don't need the mass of the styrofoam cups, but we do want the mass of the water. So I'll just put that in there. And you can go ahead and read that mass, 76.03 grams of water. It says 76.04 now. We'll go with that, 76.04 grams of the room temperature water. So speaking of room temperature, we do need to measure the initial temperature of it. So I'll go ahead and put my insulated lid on top. And the room temperature is about 20 degrees. Yeah, it's about that. So I'll have the camera zoom in on the thermometer. I'll give you a reading to the 10th. Can you see it? Okay. It's always good to let the thermometer kind of catch up with what the actual temperature is. So yeah, it's between 20 and 21. I'm going to estimate it's about 20.1. 20.1 degrees. 20.1. Okay, so now we have a mass of the water and the initial temperature of the water. I'm going to take some of my ice, which is right at its melting point. Maybe I'll take 2 of these chunks of ice out of the freezer. I'll put a couple of chunks of ice in there, and we're going to let the temperature cool off, so the water in the cup will be giving heat to the ice, causing the ice to melt. All right, so a couple of nice hearty chunks of ice. Come on. All right, in they go, and we'll stir. And of course, the temperature of the water, you'll see it doesn't take very long, starts to go down. Now what we're going to do is we're going to just let that ice melt as the water that was in the cup gives heat to the ice. That's what we find. That's the law of conservation of energy. The amount of energy the water is losing equals the amount of energy that the ice is gaining. So temperature's almost down to 10 already. We'll just do this. At the end, there still should be some ice in here. I'm planning on not melting all of the ice. I don't know if you can hear it stirring. There's still some solid ice in there, and the temperature's now below 10. So we continue to stir. We're hoping that the temperature's now down almost to 5. I want to get the temperature right down to 0 degrees so that there really is no change in temperature for the ice. The ice is starting at 0, and all the heat that the water is giving it is just going to changing its physical state, not changing its temperature. That's what happens when something is changing physical state. The temperature of it doesn't change, just the physical state of it. We're getting close. We got about 3 degrees right now. Now I'm going to go ahead and let the camera see this. We'll keep letting that melt down and cool the water off. Can you see it? All right. And temperature's now down to 2 degrees. We're just going to try to patiently wait until it gets down. Let's say just if it can go down to 1 degree, we'll say that that's good. I can still feel solid ice in there, which is very important. Because if all the ice melts, then the temperature of the water is not going to keep going down. It'll just stop changing. It's below 2. I'm going to try to get it down to 1 degree. Let's say 1 degree is close enough. Just a couple of tenths. All right, read that temperature. See, it's about 1. Can you see it?
It's blurry.
Did it go blurry?
Blurry.
All right, sorry. Well, I will just read it and tell you. I'm going to go with 1.0 is the temperature. So now we have the initial temperature of the water, and as we have added ice and given heat away, the water is given heat away. The temperature is now 1.0 degrees. So at this point, I'm going to quickly take the remaining ice out, which here it comes. Oh, here's one of the pieces of ice. It's not all melted. Here's the other piece. Almost all gone, but there it is. Okay, so now we have our original 75 or so grams of water plus the amount of ice that melted. So let's go ahead and take the measurement of that. And that's going to be 99.08 grams. So remember, what this mass is the amount of water that we started with in there plus the amount of ice that melted. Because all that's in here is now liquid water. And it was at 1 degree, or we're assuming that there was no temperature change. So, for the ice that is. So now we can figure out how much energy the warm water gave to the ice. We can use Q equals mc delta T, the warm water change temperature, so we can figure out what the Q is for the warm water. And then that's equal to Q for the ice. And if we know how many moles of ice melted, then we can find that because now we know what the mass of it was. We can determine what the heat of fusion of ice is. And that's what your job is. Try to find the heat of fusion of ice. Good luck.